moments that have the biggest impact start from a small single act. Tallest trees from a tiny seed. Grandest monuments from a single beam. Epic journeys from a first step. Throughout history, the most transformative innovations began from the smallest spark of an idea. This is how the greatest challenges are overcome. And today, we're facing a great challenge. Energy demand is growing faster than ever before as the use of electricity-intensive technology surges around the globe. And as energy demand rises, so does the need for the responsible use of resources. For clean air, energy security, and an economical, sustainable, and reliable supply chain. For generations, Babcock & Wilcox has always found a better way to address the world's energy needs. Today, we build on that legacy, turning readily available inputs into highly desirable outputs with our revolutionary BrightLoop chemical looping technology. BrightLoop technology has been developed through decades of research and collaboration. Using a tiny particle, it achieves something mighty, the production of low or carbon-negative energy. What makes it unique, and why does it matter? This breakthrough chemical looping process is highly versatile. It can utilize solid or gaseous fuel to produce hydrogen, steam for process or electricity generation, or syngas for liquid fuel or methanol production, while isolating carbon dioxide for sequestration, enhanced oil recovery, or other beneficial uses. It can also be modified to use different fuels, giving plant owners flexibility to adapt to changes in economics or fuel availability. BrightLoop is scalable and can be used in a wide range of applications, from transportation fuels to industrial processes to power generation. It is efficient, requiring a lower capital expenditure than other technologies. BrightLoop generates high-purity hydrogen from water, isolating the CO2 without the need for expensive carbon separation equipment. It does all this using B&W's proprietary iron oxide transport particle. The process is called chemical looping because the transport particles continuously circulate through the hydrogen, fuel, and air reactor vessels, moving oxygen from one chemical reaction to another. For hydrogen generation, the transport particles enter the hydrogen reactor and take oxygen from the injected steam water molecules, producing wet, high-purity hydrogen. The steam required for this reaction is generated from the exhausted process heat, requiring no additional fuel that could emit carbon dioxide. The transport particles then flow to the air reactor, where compressed air is introduced, and oxygen is added back to the particles. This oxidation reaction heats the particles before they move to the fuel reactor. Here, a solid fuel such as biomass or coal, or a gaseous fuel such as natural gas or tail gas is introduced. The carbon in the fuel strips away most of the oxygen from the particle, and the chemical reaction produces a CO2-rich gas stream. This stream will be cleaned before it is sequestered or used by another process. The same transport particles then re-enter the hydrogen reactor, closing the loop for particle reactions, and the cycle continues. With BrightLoop technology, B&W has, once again, found a better way. From something small, a tiny particle, and the most basic of elements, we can do something mighty, make real and transformational progress on the path toward decarbonization. Its scalability, economics, and versatility make BrightLoop an effective, attainable solution to meet ambitious but critical clean energy goals. And we can't wait.